Okay, so this guy, number 3, we won't do number 4. We want to simplify this. We never want a radical on the denominator. Technically, is there a radical on the denominator? Technically, yes, because how else could you write 10 square root 2t over 3? 10 root 2t divided by root 3. And 10 is the same thing as 10 over 1. So you can just, it's basically on the numerator. If it's out front, it's the same thing as being on the numerator. So what would I need to multiply top and bottom by? Root 3. Okay, so multiplying, because we want to get rid of, we always want to get rid of 2 things on denominators. The first is a square root. If there's ever a square root on the denominator, you have to get rid of it. What's the second thing that does not belong on a denominator? A negative. If there's ever a negative, we need to move it on top. Okay, so on the numerator, what's left over? 10 root what? 6t divided by just 3. Root 3 times root 3 is 3. Skip that. Okay, so that's just like what we did here. So today we're going to look at what do we do if we want to rationalize, and there's a binomial, either on the numerator or the denominator. So let's look at the first example. Where's the problem? The root 3, right? We cannot have a radical on the denominator. So that's a problem. So I need to multiply top and bottom by root 3. However, if I want to multiply the numerator by root 3, guess what we're going to have to use? We need those brackets, so, which is basically distributive property, right? We need to distribute that root 3 in. So if we distribute root 3 inside, what is root 3 times root 5? Root 15 plus, what is root 3 times 2? 2 root 3. They're not like, so we just write them beside each other. Divided by root 3 times root 3, just 3. We wouldn't say root 9, just say, right, which is 3. Is there any simplifying to be done here? No. So that now it's good. 15 we can't break down because the only factors are 1, 5, 3, and 15. None of those are perfect squares. And 3 is prime. Okay, so here's where it gets interesting. Where's the issue? The 2 radicals on the denominator. Even if there's just 1 radical on the denominator, that's an issue. We can never have a radical. So how do we get rid of it? Well, this is where the conjugate pair comes in. So remember, the conjugate pair is a difference of squares. So if I had, say, a root b plus c root d, what would be its conjugate pair? It would be the same thing except for minus c root d. Okay? That would be the conjugate pair. We want to make a difference of squares. Okay? Our goal is to make a difference of squares. And so I have to multiply the top and bottom by what would make this a difference of squares. Root 5 minus root 2. And what I do to the denominator, I also have to do to the numerator. So we're going to multiply the numerator and denominator by root 5 minus root 2. Let me zoom in so you can see that a little better. Boom. How's that for zooming in? So it's exact. What we want to do is keep the multiply top and bottom by the denominator, the identical denominator, just opposite sign in the middle. Whatever's there, top and bottom. Even if one of the terms doesn't have a radical. Okay? So if I had 7 over root 5 plus 2, okay, only the root 5 is the issue. But because it's a binomial, I would still have to multiply top and bottom by root 5 minus 2. The exact same thing, but opposite sign. That would be its conjugate pair. Even if only one of them has a radical. It's the only way to get rid of the radical is to make it a difference of squares. Okay, so this guy, the one on top, let's simplify it. 7 times root 5. 7 root 5 minus 7 times negative root 2. 7 root 2 divided by, now what's the shortcut with difference of squares? The middles are going to cancel, so we only have to multiply first and last and last. Root 5 times root 5, root 25, or just 5. Okay, so we only have to multiply, I'll use yellow, first with first and last with last. That's it. Okay, positive root 2 times negative root 2. Minus 2. It'll always be subtraction there. Okay, because it's a difference of squares, you'll never have a plus. It'll always be subtraction. And there should be no radical. So one more step. Let's simplify this. 7 root 5 minus 7 root 2 divided by 3. There's our answer. Maybe let's do this guy right here that we added. Remove this. So if I expanded the numerator of this one we added, 7 times root 5, 7 root 5, and then 7 times negative 2, minus 14, there's no radicals there, divided by difference of squares, so we only have to do first times first. Root 5 times root 5 is 5. What is 2 times negative 2? Yeah, be careful of that. It's minus 4 because it's not a radical, right? You get so used to multiplying radicals that you start doing things like 2 times 2 is 2. Like, no, 2 times 2 is 4. So it's just like silly mistakes that happen because you're so used to multiplying radicals that when there's no radical, you start to multiply easy numbers wrong. So 5 minus 4, what does that equal? 1. So we could just write this as 7 root 5 minus 14. You don't have to write divided by 1. Okay? So let's do, I'm going to get you to try number 1. So rationalize the denominator and simplify if need be. So it's just a monomial. Get rid of the radical in the bottom. So your numerator should look like 2 root 50 plus 4 root 10 initially, all over 10. Okay, so you have to distribute the root 10 into both of them. And so 2 root 5 times root 10, 2 root 50. 4 times root 10, 4 root 10. Okay, is there anything we can simplify here? The 50 can be written as 25 times 2. And the square root of 25 is 5. So we get a coefficient of 10. Because 5 times 2, right? This can become a 5. 5 times 2, 10 root 2 plus 4 root 10 all over 10. Can anything else be simplified? The 10, 4, and 10. Remember from a quadratic formula? If all 3 coefficients can be simplified, then we do that. So I'm just going to change my hat, right? So this guy, it has to be all 3 of these. If all 3 of these, it's not that dark. Green maybe? Okay, the 4, the 10, and the 10. If all 3 of those can be simplified, then we have to simplify it. It's like we're factoring out a GCF from the numerator and then simplifying. So what can you divide all 3 of those by? 2. So it becomes 5 root 2 plus 2 root 10 all over 5. Okay, so who's the problem on the denominator? The root 3x. You can multiply top and bottom by 3 root 3x, but you don't have to. The only one that we have to multiply top and bottom by is root 3x. Okay, so let's multiply the numerator and the denominator by root 3x. I'll add the brackets there. Okay, so 2 root 6 times root 3x. Coefficient's a 1 if you don't see it, right? 2 times 1 is 2. 2 root 18x. We'll worry about simplifying later. And then now the root 3x we need to distribute into 4 root 3. So the 4 times the 1, 4. Well, positive or negative? It's like a negative 4 times 1, right? So minus 4 root 3 times 3x, 9x, which we'll simplify later. Divided by, okay, the coefficient of 3 is going to stay there. 3 times what? What's root 3x times root 3x? Square root of 9x. You could write it as square root 9x squared, or how else can you write that? Just 3x, right? When we multiply two radicals that are identical, or monomials, the square root's gone. How can I simplify the first term in the numerator? 9 times 2, and there's still an x. Okay, minus, can we pull the 9 out right away? Square root of 9 is a 3, so that becomes minus 12 root x all over 9x. And the square root of the 9 is 3, so the coefficient's going to become 6 root 2x minus 12 root x all over 9x. Are we done? No. We can divide all the coefficients by 3. Okay, so that if we divide them all by 3, so we can reduce coefficients by 3. Becomes a 2, a 4, and a 3. Okay, one more thing. We need to talk about restrictions. Okay, you can just look at your new original, or you can look at this one. Well, yeah, either or. Initially, we just had the x on the denominator, right? So what's the restriction on x? It's a square root. There is a restriction here. What's the restriction? Can you square root a negative? No. So if it can't be a negative, it's going to be one of two things. It's either going to be y is greater than 0 or y is greater than or equal to 0. Question is, can it be equal to 0? No, why not? Because you're dividing. And so an x is on the denominator. Can you divide by 0? No. So your restriction is x is greater than 0. Okay? Because x is on the denominator, you can see that in the original, you can see that at the end. You can't divide by 0. It can't be 0. On IT. We got a lot to do. We might skip a couple. Okay, let's try 3. Also good though. Okay, let's just move it. Now this is a binomial. So how do I get rid of the radical when we have a binomial? Conjugate pair, difference of squares. Okay, so we're multiplying the numerator and the denominator by the identical thing but opposite sign in the middle. So root 6 minus root 3. Okay, go ahead and expand that. I'll let you do that. Because can I go just first times first and last times last on the numerator? No, because it's not a difference of squares. It's not identical, but opposite sign. I have to use FOIL. So let's do it. Root 3 times root 6. Root 18. And root 3 times root 10 plus root 30. Oh, I'm not going to have enough room. I'm going to write it down here. Okay, next we have to bring in the 5. So root 5 times root 6, root 30. And 5 times root 10, root 50. One color. All divided by, now this guy, can we just go first and first, last and last? Yes. So root 6 times root 6, 6, minus 10. Okay, we have a whole bunch of simplifying we can do. Let's start with the 18. It's 9 times 2, so how else could I write that instead? 3 root 2. Square root of 9 is 3. 3 root 2. Yes? Nope, it's minus. And it'll always be a minus sign because they're opposite signs. Because we're doing negative root 10 times a positive root 10. Right? When we do the last times last, because these are opposite signs always, you're doing negative root 10 times positive root 10. So always will be a minus in between. Root 30 plus root 30. No, not root 60. That's a common mistake. What's the coefficients if you don't see them? 1. 2 root 30. There we go. Hello, Monday morning. Plus 50 we can write as 25 times 2 or 5 root 2, all divided by negative 4. Okay, that's a problem. We got rid of the radical, but we created a different problem. There's a negative on the denominator. So let's deal with that last. Are there like terms on the numerator? Yeah, 3 root 2 and 5 root 2, 8 root 2, plus 2 root 30. Can you break down 30? No, over negative 4. Oh, there's 2 issues. Can we all, oh, the negative. Okay, what do you want to do first? Simplify or take care of the negative? You said, I heard 2 different things, so it doesn't matter. Take care of the negative? Let's simplify first. Let's simplify. You can actually do both at the same time if you want, because all we're going to do is switch all the signs. So we're going to have to make the numerator negatives. So I'll show you what I mean after. Let's simplify this first. 8, 2, and 4, we can divide those all by 2. So 4 root 2 plus just root 30 divided by negative 2. So if we want to move the negative up top, and you don't have to write this next step unless you want to, what we're doing is we're putting it in front. I'm just going to move it to the top. I'm putting it in front of both of these. And so normally we wouldn't write it like that if we want to move it to the numerator. So you're just switching all your signs. Everything switches its sign because we're going to distribute that negative in. Okay? So instead we'd write this as, if I distribute the negative in, negative 4 root 2 minus root 30 all over 2. Okay, so what you can do if you want to get rid of the negative on the bottom, you just switch the signs of everything. All the signs switch. Negative, negative, positive. You could really quickly even just do this. Negative, negative, positive. Right? Just switch all the signs. Pardon me? No, but it has to be all three. Because basically you have to be able to factor it out of the numerator to simplify it with the denominator. So it has to be everybody. Okay? So you can't, do that. Alrighty. Let's skip 6 for sure, but maybe try, oh no, this is 6. My numbering was off. It was not on my sheet, not yours. I like this one. Are your numbering off? No, is this a number 5 for you? Oh, that's good. No, we are going to skip 6. I'd like you to try 5. So rationalize 5. We'll skip 6. So distributive property here. And then different squares, first times first. Minus, what did you get? Minus what? Minus 16 last. Negative 4 times positive 4, minus 16. Okay. So restrictions. Okay, x has to be greater than. Okay, now, could it be equal to 0? Let's check. If I put in 0 here, 5 times 0 minus 4. Okay, you get what? 5 times 0? 0. Square root of 0? 0. So I get 0 minus 4. Does that give me a 0 on my denominator? No. It gives me negative 4. Is that valid? Sure. So it actually can be 0 in this case because it's not a monomial. Because it's root 5x minus 4. But there is a restriction that's not stated here. So it has to be greater than or equal to 0, but it can't be equal to something. And so our denominator can't be 0. You're right. So what would make our denominator 0? Well, if we look at our simplified expression, what value of x would make our denominator 0? Think about zeros when you were finding zeros and you had factored 4. I think that's right. Oh, okay, yeah. What did you do? 16 divided by 5, 3.2. That's right. Right? So remember, second, opposite sign, second over first, 16 over 5. 15, another way to think of it, 15, blah. 5x minus 16 can't be equal to 0. If I add 16 to the other side, and then divide by 5. So x can't be equal to 16 over 5. That's a tough one. You probably won't see anything that, but you will actually, for sure, next unit. I get to do rational expressions. You'll love it. It's good. Good times. Okay, last one on this page. Do you feel like you get the idea? No? We'll do one more. What would I have to, oh, this is good because it's a little different. What would I have to multiply top and bottom by? 2 root 2 plus 3 root 3. It has to be identical, just opposite sign. As long as it's a binomial. Doesn't matter what's there, identical but opposite sign. Okay, this is fun. There's a lot of 2's and 3's in here. So the numerator we have to FOIL because they are not difference of squares. So we just got to FOIL it. 2 root 2 times 2 root 2. 2 root 4. Or 2 times 2 if you want. You could just say 4. That's great if you can do that in your head. That makes me happy. Now, root 2 times 3 root 3. 3 root 6 plus, now we have to go this guy. Root 3 times 2 root 2. 2 root 6 plus, and this is a 1 root 3 times a 3 root 3. 3 root 9, all divided by, okay, so is the bottom a difference of squares? Yeah, so just first times first. 2 root 2 times 2 root 2. For 8. Yeah. Why is it 8? Because it's going to be 4 times 2. Root 2 times root 2 is just 2. 4 times 2. So 2 times 2 is 4. Root 2 times 2, root 2 is 2. Minus, always a minus. Okay, 3 root 3 times 3 root 3. First, 3 times 3. 9 times root 3 times root 3 is just 3. So on the numerator, we can simplify a bunch of stuff. The first thing is 2 root 4. Because what is the square root of 4? It's just 2. What else can we simplify? The 9. So we have 3 times, what's root 9? 3. What else can we simplify in the numerator? The root 6's. 3 root 6 and 2 root 6. 5 root 6. And then denominator, 4 times 2 is 8 minus, that's 8 minus 27. What's 8 minus 27? Negative 19. That's an issue. We can fix that issue later. Okay, 4 plus 9, 13. So I added the 4 plus 9 together, right? This 2 times 2 is a 4, and then 3 times 3 is a 9, so I made that 13. How do I get rid of the negative? Switch all the signs. So we get negative 13 minus 5 root 6 all over 19. We just move the negative to the numerator instead. And I think we're done with that. We are definitely skipping this guy for today. This guy, and going down to the bottom two. Yeah, just because of time. The worked out solutions on the math website if you want to look at it. But let's look at these guys, because these guys here make wonderful test questions.
Will this stuff be on the test one? Like,
yep, all of this stuff is going to be on your exam. And these ones I especially love for written response. Okay, so what's beautiful about these guys is that they're monomials. Right? Don't have to worry about conjugates. We have two options. We can choose to rationalize first, then simplify, or we can simplify, then rationalize. So I'm going to show you both cases. So this one will be case 1. If you want to rationalize, then simplify. Now the problem with this case is that you're going to have large numbers. So you have to be very careful when you're simplifying. So what do I have to multiply top and bottom by? Root 6t squared. Good. Top and bottom. So this is where it gets huge. What is 260 times 6? Oh, lovely. We need to find the largest perfect square that goes into that. This is where rationalizing first has a disadvantage. Okay, to t to the power of 6, yep, all divided by, what's 6t, root 6t squared times root 6t squared? 6t squared. Okay, so far so good. The largest perfect square that goes into 1560. Well, we can also simplify it multiple times if we have to. It's really hard to know. You can start dividing by your usual ones. So 144, 121, 100 obviously won't, 81. Then there's 64, I can think. And there's 49. Having much luck? Nope. 36. 25 won't. It's not a multiple of 25. 16. Nope. 9. Nope. 4. Yes. Okay, we don't know if there's any larger, but probably not. 4 times 390. So you might have to, we will have to double check that 390 can't be broken down. But let's break this down into 4. Now, it's not just 4, because what else can you square root? So 4 times 390, yes. But what else can we square root? Can we square root t to the 6? Yes, because it's even, right? Divided by 6t squared. So we want to double check, can we break down 390? Because if 390 could be broken down, there was a larger one. We can do that. Let's pull the 4t squared out. So when we pull 4t or 4t to the 6 out, what's the square root of 4? It's going to be a 2. What's the square root of t to the 6? Thank you. Excuse me. T cubed. So what's our coefficient going to be now? 10. We multiply it by the 5, right? 10t cubed root 390 all over 6t squared. So just to make sure, I need to make sure that I can't simplify 390 any further, that is the largest it can be. Now we need to probably look up our larger perfect squares. Remember, the shortcut to look them up is go y equals x squared and go to your table. And so some of them you might know. We need to go numbers smaller, at least half the size of 390. So 196, 169. We need to try. Now, has anyone tried those yet? Can it be broken down? So there's, what were they? Don't have them handy. There's 196, right? 169 would have been, yeah, that makes sense. Okay, no. So keep going, because we have to make sure it's not 144 won't. Doesn't make sense. So if you keep going, guess what? You won't be able to simplify it. You can keep going, and there are no more perfect squares that will divide into it. So I'm just going to tell you now. You keep going through, double checking, making sure. Okay, so you go through them all. It can't be simplified further. So we're good. The 390 is good. The root 390 can't be simplified. But what can be simplified? The 10 and 6, okay, good, can be reduced to 5 and 3. What else? The t's, t cubed divided by t squared, is just a t on the numerator. You have 3 on the numerator, 2 on the denominator. You can simplify that just to 5t root 390 all over 3. The last thing we have to do is state a restriction. Okay. This one's fun. Let's look at the original. We have a square root, right? And we know you can't square root a negative. But what happens when we put in a negative for t in both of these? And you raise it to an even exponent. It turns positive. So in this case, can we have a negative number? Yes. So yes, it can be a positive and a negative number. You also always have to double check 0. Can it be 0 though? Can it be 0? That's the denominator. If I put in 0 on the denominator, guys, don't run away now. This is really important for your quiz tomorrow. If I put in 0 on the denominator, 0 squared. 0 times 6. 0. 0. Square So the only restriction in this case is t can't be 0. Okay? Because of the power of 4 and the power of 2 inside that square root, if it was negative, it comes out positive, no big deal, but you still have it on the denominator, and so it can't be 0. All right, one more question, and then we are officially done. And I know it's long. I know you're tired. It's Monday after Wagathon of all things. But last question. And the last question we're going to simplify before we rationalize. Okay, I'm going to go a different route. Simplify, then we're going to rationalize. As opposed to rationalize, then simplify. Okay, so remember back in the lesson we did yesterday, I don't know if you remember this, we can multiply radicals with radicals, we can divide radicals with radicals. So 8/10 over 12, we can actually simplify that. I can take my calculator, go 8/10 divided by 12, math, enter, enter. It'll reduce the fraction for me. Essentially, we're going to divide both of them by 6. I can reduce 8/10 and 12. Okay, I'm going to reduce that to 135 in here and a 2. What else can I simplify? The t's. T cubed divided by t is just going to be a t squared, and this t will be gone. So we're simplifying inside the radicals. So we're going to be left with 135 t squared divided by just root 2. Now, before I rationalize, I'm going to see if there's anything else I can simplify. So what do I need to check? The one perfect square is 135. Okay. Well, it adds to 9, so 9 goes into it. 5, 6, 7, 8, 9. It's 81. No, 81 won't. It's double, right? It's 162. So 9 times 15. And you can't simplify 15. What else can you break down in the square root or take out? The t squared. Ah. Okay, so this is going to be 6 root. We can do 9 times 15 or 9t squared because I can square root the t squared all over root 2. See how nice and small my numbers are getting? It's wonderful. So we broke down 135. I'm simplifying the 135. I found a perfect square that will go into 135. It's 9. 9 times 15. What is the square root of 9t squared? This becomes a 3t. We have to multiply it with 6. So that becomes 18t root 15 all over root 2. Great. Now, are we ready to rationalize? Look how small our numbers are now. So top and bottom, we're going to multiply by root 2. So that gives me 18t. Ah, that's not an eraser either. Okay. 18t root 30 divided by, what's root 2 times root 2? 2. One more thing we can simplify. 8 divided by 2. So 18 divided by 2 is 9. Okay, one more thing we need to write is restriction. So let's look at the original of this guy. Okay. So here, it's hard to see. I'm going to erase this. Restrictions. Now, this is a square root, so there most likely is a restriction. Now, these are to the power of 3 and power of 1. What happens when I take a negative and bring it to the power of, 3? It's still negative, and so that would make it a negative. So in this case, can we have a negative number? No. Can we have 0? No. It's on the variable's on the denominator here. Right? So you can't divide by 0. So t has to be greater than 0, not including. There it is. Sound good? We're done. long one, but we made it. So your assignment, yeah, the long one. So as long as you've already done yesterday's stuff, you want to make sure you've completed the Friday's assignment. 289, 293, number 6, 8, ABC, 9, 10, 11, 13, 14, 17, and 19. Okay, so that, especially if you still have to do Friday stuff, Friday and Mondays, it's good stuff to do for studying, your quiz, tomorrow.